because we cannot solve for y. This is a product, function 1 and function 2, and actually function 3 inside. First function prime is 1 times tangent y plus x times tangent prime, which is secant squared y, times the inner function prime, dy over dx. So remember, every time you have a product, you have to have a sum of two terms. Plus 1 over 2 the square root of y, but times the inner function prime, which is dy over dx. And now again we have function 1 and function 2. 2x times y plus x squared times dy over dx. Let's stop for a second and see if we have any questions.
No, so far it's making sense.
You feel much better now after we, right? Because we had, yes, it needs practice. You need to see it. Once you see it several times, it will stick. Okay, so now I see the variable is in 3 different terms. So I'm going to move this term to this side, becomes negative tangent y, and I'm going to move this term to this side, becomes negative x squared. So I have x secant squared y plus 1 over 2 the square root of y minus x squared, and all of them have dy over dx. This one with positive, this one with positive, but this one moved will be negative x squared. I also pulled out dy over dx. And then I have 2xy minus tangent y. So then dy over dx must be this ratio. This 2xy minus tangent y over all this. X secant squared y plus 1 over 2 the square root of y minus x squared.
Thank you very much.
Thank you. Next question, please choose anything.
How about
yes?
Another one from number 2? Maybe?
Yes, yes.
Just because the limits
yes.
were so long ago that...
Yes, that's why I insisted please redo your tests every weekend, because to keep that fresh. Right. You can get away from the limits. You'll see what happens in the next course. So don't think that you're done with limits. They'll follow you everywhere you go.
Could we do E or F?
I'm sorry, which one?
E or F.
E or F? Yeah, we can do both. So we have limit as x approaches negative infinity from x plus the square root of x squared plus 2x. This approaches negative infinity, and all this approaches infinity. And this is an indeterminate case. We have to do this first. We have to identify the case. And now what do we do? What do you recommend for this particular type? Anyone?
guess do we need to manipulate it to get it as one of the other indeterminate cases?
This one is the one that it doesn't really work to change it into 0 over 0, at least not at this point. So I needed something to do before that. But yes, the idea is to remove the indeterminate case. What did we do in the past with this type? Here's my hint.
Rationalize it?
Thank you very much. So when you see a radical and a situation like this, we should always think in terms of rationalizing. Good point. Okay, so now limit as x approaches negative infinity. The denominator is very clear. I have to work on it in a minute. But what about the numerator? What do we get in the numerator?
X squared minus the x squared.
Yes, that's the best way not to be safe rather than sorry. Good. So then we have limit as x approaches negative infinity. And the numerator will be negative 2x. Because x squared minus x squared will go away, and then minus 2x. So obviously I have to start by factoring here. So underneath, what is the degree? The degree is 2, so therefore I have to factor out x squared. And this is 1 plus 2 over x. Is this okay?
So you factored out the x squared. Oh, okay. And then since you divided by x squared, it became...
Yeah, because whatever I factor, I can factor even a million if I want to, as long as when I multiply them again, I get that, right? So x squared times 1 is that, and x squared times 2 over x is 2x. So now I have a product. So this is the square root of x squared times the square root of 1 plus 2 over x. And I have to be very careful with this, because x approaches negative infinity. This piece is basically the square root of x, which is x if x is positive, or negative x if x is negative. But x approaches negative infinity. So now this has to be replaced by negative x, because x approaches negative infinity. So therefore, limit x approaches negative infinity, the numerator is negative 2x. But now I have x. This piece is the absolute value, but it's negative x with minus in front, positive x, the square root of 1 plus 2 over x. Yes, of course, I'm going to factor out and simplify with x from the top. Now, at this point you could, I don't know, I've never thought of doing that, but you could at this point, instead of factoring out x squared, we could, and we can go back and check, we could use L'Hopital's rule. Can I? The numerator approaches infinity, and the denominator approaches negative infinity. Yes, I could. We could. So we can go back. So limit as x approaches negative infinity, negative 2x. Now this is very simple. It's this situation. I simplify. And now the numerator goes to -2. This approaches 0, and it's 1 plus 1. So this is negative. Oh, I meant to write 1. So -2/2 is -1, which means y equals -1 is indeed a horizontal asymptote at -infinity for sure. Now, if we had stopped, I'm curious now, if we had stopped here with -2x and x minus the square root of x squared plus 2x, and use L'Hopital's rule, which we can. Why? Because the numerator goes to infinity. This one goes to -infinity, and this one goes to -infinity. -infinity minus infinity is not an indeterminate case, it is infinity, or -infinity. So now I can use L'Hopital's rule, and let's see what happens. The numerator is -2. The denominator is 1 minus 1 over 2, the square root of x squared plus 2x multiplied by 2. So as x approaches infinity, this piece approaches 0. Very elegant, and I still get, yes, -2/1, yes. -2, yes. Okay, sorry. I have to get the same answer, right? So I just wrote, it's times the inner function prime, which is 2x. So now we have limit as x approaches -infinity. The numerator is -2. And now the denominator, and I have to flip the denominator. So yeah, it becomes more difficult now because I'll have the square root of x squared plus 2x and minus x. No, I don't recommend it. Even so, I don't recommend it. I don't really recommend L'Hopital's rule on these situations. Period. So this is a much better approach to rationalize. After you rationalize, you have to factor and fully simplify. And once it's done, you have -2 over this, which is very easy now. This approaches 0. The numerator approaches -2. The denominator approaches 1 plus 1, which is 2, and that the answer is -1. So even when we simplified it as much as we could, I would not recommend it. I was just curious. I've never tried it. For infinity minus infinity is not really a friendly situation with L'Hopital's rule. They don't mix well together. That's what E. And you also asked about F. So this is a problem from a previous test. So e to 4x minus e to -4x divided by e to 4x plus e to -4x. This is another situation in which the numerator approaches infinity, the denominator approaches infinity, but I wouldn't work it with L'Hopital's rule, because it's much easier to factor out, again, the highest power in this case. And then you get 1 minus e to -8x and 1 plus e to -8x. These two go away. This approaches 0, this approaches 0 because it's negative when x approaches infinity, and the answer is 1. So then y equals 1, horizontal asymptote at infinity. What do we continue with? I also want you to finish up the homework because a lot of problems, I have to choose problems from WebAssign now. So whatever you want to continue with. Which problem? So which one we go on with?
Maybe something like number 3, part B, or
3, part B. Let me take a look.
yeah.
2, 3, part B. We have to start from scratch because I need to find the velocity. So we have,
Oh no.
oh, you said 3. I'm sorry. I looked
Yep.
at 4. Sorry. Part B, yes. So we have sine cubed of e raised to cosine squared x. So we have plenty of functions in here, and I have to start with this one. This one will be 1. This will be 2. This will be 3. This will be 4. And this will be 5. From the outer to the innermost. So first 3, I subtract 1 from the power, and I copy everything else. Times. I only differentiated the power. Now I have to differentiate sine, which is cosine of e to cosine squared x. Times. Everything is multiplied. No addition, no subtraction. This is the chain rule. Times the inner function prime, e to cosine squared x, times the power, 2 cosine x. Finally, times the inner function prime, negative sine x. So first the power, and I subtract 1 from the power. Then I differentiate sine and get this. Then I differentiate the inside and I get this. Now I differentiate cosine squared, so I have 2 times cosine to 2 minus 1 times the inner function prime. I will only do this. I will multiply negative 1 by 2 and by 3 and put it in front. Nothing else can be done. So this is negative 6. I'll put sine x, cosine x. I will put e to cosine squared x and then multiply these two as they are. Sine squared of e to cosine squared x and times cosine of e to cosine squared x. Is this okay? Any questions?
Yeah, that's fine. Thank you.
Thank you. Anything else? What do we continue with?